The chemical hazard tool provides operators situational awareness about the position of toxic gas clouds after accidental releases. The chemical hazard tool has a map-centered user interface and calculates potential hazard footprints based on real-time information from sensor data, meteorological data, and input by first responders. Let's take, for example, the Rotterdam area, which has a lot of petrochemical industry. All kinds of toxic chemicals are stored and transported in this area. The operators of the tool are trained hazmat specialists who must take decisions and give advice about measures that must be taken to avoid casualties and reduce risk from exposure of own personnel and the general public to toxic chemicals. For its calculations, it makes use of high-resolution meteorological data that is available for the whole of Europe. Here we see a visualization of the wind data that is used by the tool. When an accident has just occurred, it is very hard to estimate how much gas is being released and how long it will take to stop the release. Also, the wind direction and speed are only known with limited accuracy. The first responders need to gain situational awareness fast and make decisions on which actions to take. The template view gives a first indication of the area at risk. It is the area in which there is a possibility that the toxic plume will arrive. Based on this first indication, the operator can decide where additional gas measurements should be made. After entering more information about the accident, a dispersion calculation can be started and a more accurate picture showing the length and width of the gas plume shown. Important parameters like the release rate, release duration, and atmospheric stability can be modified and have significant influence on the calculation results. Using the time slider, the predicted future position of the cloud can be visualized, for example in 30 minutes or in 2 hours. The contour lines represent the levels of concentration that are related to 3 levels of toxicity: life-threatening, possible health hazard, and noticeable. Based on this information, the first responder can recommend which actions to take, for example whether the public should be advised to stay inside and close all windows. A list of chemicals for which these levels are known is integrated and can be selected. Expert users can make a more extensive analysis of the uncertainties in position and size, which are due to uncertainties in, for example, the amount of released gas, the wind direction, and wind turbulence. The ensemble view shows a few examples of possible positions of the plumes. The trajectory view shows a large number of possible paths of the cloud centre. It is possible to connect a handheld GPS device to the system. To connect, just enter the URL of the assistance server, choose some preferences, and the GPS device is connected. The administrator can assign personnel, vehicles, and other resources to groups and specify some attributes so that the system knows how to handle their data. In the chemical hazard tool, the positions of registered vehicles and personnel are shown on the map. Being connected to the SAS, incoming data from sensors is received automatically and sensor data is shown on the map. When the firefighters approach a gas cloud or the gas cloud approaches them, they receive a warning from the system. The operator can activate overlays which show vulnerable locations, for example hospitals, schools, and elderly homes where rescue actions might become necessary. The chemical hazard tool has been developed in close cooperation with first responders to make sure that this is in line with their needs and optimally supports their situation awareness and decision making. With this module, hazmat officers have better insight in the development of toxic gas clouds and the dynamic changes in the environment, thus supporting their decisions to make the situation safer for everyone.